This is Brent with Lykins Motorsports, part 2 of the 465 cubic inch tunnel port FE build. And this probably won't be a very long video today. Don't have much to do, but waiting on pistons to be made and waiting on main bearings to come back from Calico. I had those coated. Do have rod bearings now, so I can check rod bearing clearances and get those dialed in, and just a few things to wrap up on the engine block itself. First thing I did this a day or two ago, the relief valve. 427s have this in the center oiler. It's actually in the top of the lifter valley, at the plug at the rear of the block up at the top. On a side oiler, it is right here, and this plug right here. So you can do this a couple different ways. The way that I like to do it is I really just don't like for that spring to work very much at all. And some guys put a solid plug in there so that it doesn't bypass. The purpose of this was to bypass and bleed off oil pressure. So what happens, there's a passage in between. This is your main passage that runs down the side of the block here. It dead ends here, and then there's a little passage in between these two. So when you get, really high oil pressure, it pushes this spring and it relieves, dumps off oil pressure out of this hole, just dumps it back into the pan. So back in the 60s, the oil pump that was specified for these was a high pressure pump, and it wasn't uncommon to hear, 110, 115 pounds of oil pressure, and they would bleed it off back here. We don't do that these days. I just run a Melling high volume pump, and it's about a 75, 80, 85 PSI pump, depending on the bearing clearances and other things. So I really don't want this spring to do much. And like I said, some guys put a solid plug in here so that it won't bypass. I buy these plug kits, relief kits from Precision Oil Pumps, and he's got a stouter spring than what the factory had back in the day. And in addition, I put a shim, about a 1/4 inch shim in front of the spring, so that kind of stiffens it up a little bit more. The good thing is that when we're ready to prime the oil pump later on down the road, I can see what it does, and it's easily changeable from the rear of the block. Do have our studs in. I think I showed that the last video. Rear cap gets bolts to clear the oil pan. All right, I'm going to roll this over and show some detail work that we've done at the top. Okay, last time I talked about putting this, the restrictor down inside that hole, and that hole has been tapped to an 1/8 inch pipe thread. This is the passage that feeds your lifters, and there's several ways to do this. In a drag race scenario, depending on the spring pressures and everything, we may even close all this off together, that the lifters will oil with splash, and that's okay as long as you have oil going to the heads to feed the rocker arms. In a hydraulic roller or a hydraulic engine, I don't generally touch these. In a street solid roller scenario, I will usually restrict these. And what I've done is, this is an 1/8 inch pipe plug. It's got an 1/8 inch hole in the middle of it that acts as a restrictor. So you can see how far this has been necked down. The engine would be trying to push, the equivalent of this amount of volume of oil through the lifter to the lifters, and you don't need that much. So we're going to neck that down. And like I said, this has already been tapped, and what I like to do is put just a little bit of oil on the plug after heat cycles and, you know, being tight, sometimes it's very hard to get these plugs back out. So it helps if I have the right size Allen wrench. So what I was saying, good to put a little bit of oil on the plugs. Wow, I'm really doing a good job today. Can't even get this started. There we go. Yeah, so you can see we got an installed restrictor. And we're gonna do the same thing to this other side. A little bit of oil. Maybe the key is it's easier to do if you're not looking at it. I don't know. Okay. So we got that one. And we've got that one. It's kind of hard to see down in there. So we're going to follow that up with the 1/4 inch pipe plug that you normally put in here. And put some oil on that. And get that started. Okay, so got that buttoned up. That's it for the gallery plugs. And here's the plug that I was talking about earlier on a top oiler block. This one right here will have the relief valve behind it. Okay, so let's check some rod bearing clearances. We're using a K1 rod, Big Block Chevrolet rod journal. This is a 6/800 length rod, and these things will hold some major horsepower while being pretty light. If you compare this to some of the other brands of connecting rods, they're quite a bit lighter, 50, 60 grams at least, I think. I'd have to check on that and get back, but just a nice overall piece. I use a lot of them. Come with an ARP 2000 bolt. Pretty nice stuff. So before we check rod bearing clearances, got that lubricant all over my fingers. I always check 0 on my mic. I do this every morning and make sure that it's on 0. So if you watched my other video where I was doing the rod bearing clearance check on the small block Ford, the general gist of it is you measure the crankshaft journal diameter and then set your bore mic to that, and you're measuring the difference. So we have a pair of Calico coated Clevite rod bearings, and again, for the Big Block Chevrolet, these are upper and lower. You have to make sure that those go in the respective spots. The upper goes into the upper part of the rod, the lower goes into the cap. For these rods, they're 7/16 by 1/800, so they torque at 30 pound-feet plus 60 degrees. And you can check that with a stretch gauge. I use a snap-on digital torque wrench to do this. You know, they make the little attachments that you can buy that have the 2 pointers that you line up or whatever, but I don't think they're very accurate. So I've got this one set at 60, and what you do, you pull to 30 pound-feet, and then you cycle through, and then you go through and pull your 60 degrees to get the torque on them. So I've already done one, and I keep a record. I keep notes right here, and then when the engine is finished, I type all this up and give the customer a nice build sheet. But this is the identifier of the rod, 0251. You see 0251. That's the bearing clearance. This is the bearing that I use, and I need to write down the diameter of the crankshaft. Forgot to do that. This crank has not been balanced. It has not been final washed yet, but the journals are clean, and it lets me measure. So we've got basically 2199 and a tenth. So I will put that down. 21991. And it just helps me for records purposes when I do other builds to know, about what size bearings I have to use based on the journal size and based on the rod and everything. You can usually breeze through rod bearing clearances pretty quickly. What I usually do is I'll get, a set of different bearings. This is a standard set. You can get this in an HX bearing, which means 1/1000 extra clearance. You can get it in an H1, which means 1/1000th less clearance. You can mix and match to get the clearances you want, but I'll usually, lay out 2 or 3 bearings, and I'll go ahead and check, one rod and see what bearings that I'm going to have to use for the rest of the rods, and then I'll go ahead and load the rods up with those bearings and then just blow through them. So it's pretty easy to do. What I find helpful is a mic stand, and when you go to set your bore mic to that, it helps when everything is positively located. So I actually checked this one last week, and this goes to show you how accurate you can be with this stuff even over time. I got 0022 last week, and I got 0021 this week. We're talking a 10,000th of an inch, which is pretty stinking small when you sit down and think about it. So we got this one. I'm going to stick with my measurement from last year. It's a little bit harder to measure this stuff on camera, so I'm trying to focus on the camera and everything else. So I'll stick with this dimension, and I'm going to roll through. I can go ahead and check number 5 since it's on the same rod journal, and then just roll through. So quick tip, lots of lubricant, and they're usually lubed from the factory where they torque them and honed them. But it's good to go ahead and lube them again. And you want lubricant under the head of the bolt and around the threads. You go to screw those in before you torque them. Just make sure everything is well lubricated before you start pulling torque on it. We're going to go ahead and set this up, and I'll verify the stretch with a stretch gauge. This is the ARP stretch gauge. And if you look at the end of the rod bolt, it's got a little divot for your dial indicator to sit down inside. And on the hind end of the rod bolt, you'll see another little divot, and that's for your anvil to sit. Okay, so I like to do this. Everybody has a different way of doing it. But if you notice, you can actually make the needle move just by wiggling it around. So I kind of like to have everything stationary in a spot where it will not move. The bolt is not torqued, it's in a free spot, so I'm going to take my dial indicator and zero it. And then when I torque the rod bolt, I will check this one again and show the difference in the stretch. Okay, so we have our rod bolt torqued to 30 pound-feet plus 60 degrees, and my stretch gauge is back on. And so it's now going to show the difference since we zeroed it at the non-stretched length. This is the stretched length. We're sitting at like 6/1000 and a tenth or so. I told you wrong before. It's not a 1/800 bolt. It's a 1/600 bolt. So recommended stretch is 6/1000 to 6/1000 4/10. So we're in good shape. Depending on the rod manufacturer, they will want you to check the rod, the torque different ways. Some of your lower end rods will just give you a torque spec. A lot of your higher end rods will give you a torque angle or a stretch. So it's nice to have the tools to be able to check all these, and this one's in good shape. So we're gonna zip through and get the rest of these rods, the bearing clearances checked. All right, so we got all of our bearing clearances checked, and just a couple of notes here. This is the journal diameters for the scat steel 4 1/8 inch stroke crank. On journal for journals 1 and 5, we're at 21991, and then 2 and 6 is 1992, and so on and so forth. Just a pretty good testament to how, you know, nicely ground these scat cranks are. And this is what I pretty much always see. I rarely see more than a tenth or two difference. And, you know, I didn't show it on video, but I will sometimes check at different points on the journal, and also 90 degrees, so I can see if there's any out of round or taper issues. And, you know, it's just, these cranks are just really nice pieces. So here's our bearing clearances for rods 1 through 8. And I think some of you have asked in previous videos what I like to see as far as bearing clearances. And on these FEs with a big block Chevrolet rod journal, I pretty much always run the coated bearings, and this is pretty much where I stick them. If there's a rule of thumb that you use 1/1000th clearance per inch of journal. So it's a pretty good rule of thumb. It's worked for me, or a variation of that has worked for me for a long time. So for instance, if you have a 750 main journal, then if you aim for something like a 0027 or 0028 main bearing clearance, you're going to be pretty safe. On this situation here where we have a 200 rod journal, you know, if I'm somewhere around 2.2 rod bearing clearance, then I'm going to be fine. If I don't use coated bearings, I usually allow myself a little bit more clearance. So, you know, this would be maybe a half thou larger, you know, 3.2, something like that. And same deal with the rod bearing clearances. But the coated bearings offer, you know, a lot more support and a lot more protection against, you know, startups. And, you know, I've even heard issues where guys have plumbed their oil coolers in backwards and started the engine dry, and the coated bearings saved them. So I try to put those in every engine that I build. And it's a little bit more expense, but it's just a higher notch of you know, of building, of protection. So I'm pretty pleased with how this turned out, and we're gonna get these rods knocked back apart, and I can't really do anything else until I get the pistons but we'll get all this balanced and the crank balanced and move on. Also, just wanted to take a second and say thank you for watching. We're closing up on 1,000 subscribers, and I appreciate you all sitting down and watching my videos. I hope it's been some help to you, and I'll post many more to come. So make sure you hit that like button and that subscribe button. Tell your friends. I know that there's not a lot of guys that specialize in FEs, so hopefully we can. The FE engine's not that popular. I mean, it's more popular than it used to be, but you know, today it's mainly small block Ford LS motors and things like that. So, you know, I don't expect a huge following, but you know, I want to help the guys out that are working on these engines. So this is Brent with Lykins Motorsports. Have a good weekend.